So
You
hi,
may
hello
please
everyone.
begin.
Yes, sir. Thank you, sir.
Thank you.
So hi, hello everyone. Yesterday we were discussing about derivatives and we calculated the derivatives of a few functions. And today we'll be starting, as we had told that today we will be starting with the chain rule. So going just, even though we have done it earlier, just going into a little bit basic, right? So what happens is, like, for example, you have one function inserted inside another function. So you can just see, like, you have got two functions, f of x and g of x, and you have got y as f of g of x. Okay. Like, instead of, like, in f of x, you have substituted g of x, right? So over here, your dy by dx, right? Dy by dx is basically dy by dx of f of g of x, right? F of g of x. So over here, what we can do is, you can just consider your g of x to be some function u, okay, some variable u. So this becomes d by dx of f of u. Do you all agree with this? Right? Because
Yes, sir.
now in place of g of x, it is just okay. So this thing becomes d by du of f of u into du by dx, right? Something like this. So dy by dx becomes df of u by du by into du by dx. So can anyone just tell me if d by dx of f of x is f dash x, so d by du of f of u will be what?
F dash U.
Okay, great. So we have just changed the variable. Everyone is able to think about this, right? We have just changed the variable from x to u. This is what we are doing. So my final answer will also, in place of x, I can just directly substitute u. Everyone agrees with this?
Yes. Yes, sir.
Everyone? Right? See, if d by dx, derivative with respect to x of f of x, right? It is f dash x. So derivative of f of u with respect to u will be f dash u. Really simple. So my first term becomes f dash u. Now let us have a look at du by dx. So du by dx is basically d by dx of g of x. So it is basically g dash x, right? Derivative of g of x, right, everyone? Everyone?
Yes, sir.
Okay, great. So this thing becomes g dash x. So now just substituting back to my final answer. So dy by dx becomes f dash of u, f dash of u. So it would mean f dash of g of x into g dash x, right? So this is what my chain rule says. So that if you have one function inserted inside another function, what do you do? First, you differentiate the outer function. Okay. Like over here, the outer function was f of x, right? And you differentiate the outer function and keep all the inside stuff as it is. So over here, what you did, you differentiated f of x, so it became f dash x, and inside the parameter was g of x. So you just substituted it as it is. So it became f dash of g of x multiplied by, then you start differentiating the term inside. So it became g dash x. Let us have a problem example at it. So you have got y is equal to sine of x square, right?
Sir,
Sine of
can
x
you
square.
repeat once again?
Yeah, sure. So what you have is, you have got y is equal to f of g of x. Okay. So you substituted g of x as some variable u. So it became d by dx of f of u. So what you did, you divided and multiplied by du. So it became d by du of f of u multiplied by du by dx. So differentiation with respect to u of f of u became f dash u, right? F dash u. And this thing du by dx became g dash x, right? Because d by dx of gx, u is equal to gx. So this became g dash x. So g dash x came as it is, and f dash u. So I substituted back. So it became f dash into g of x into into g dash x. So basically what is happening is I have one function nested inside another function. My outermost function is f of x, right? My outermost function is f of x. So what I do, I first I differentiate the outermost function and keep the parameter inside as it is. After that, I differentiate the inner function and multiply both the results, and I get my final answer. This is the basic thing of chain rule. So over here you can see you have got sine of x square, right? Sine of x square. So over here your f of x. So it is something like if you just try to see it as f of g of x. So your f of x is basically what? Tell me, who will tell me the f of x and g of x? Just compare it with
Sine
this
and
thing.
x square.
Sine
Sine
Great.
and x square.
So what is your f of x?
Sine
F of x is what? Great. And g of x is
x square, sir.
what? Gx. What is your g of x?
X square, sir. X
Great.
square.
It is x square,
X square, sir.
right? So dy by dx is basically d f of g of x by dx, right? So again, like if you just start doing the same thing, so you will get with the final result as this. So it is f dash of g of x into g dash x. Can you just tell me what is the value of f dash x? What is f dash x? Derivative of
Cos
sine x.
Cos x.
Cos x is
And what is g dash x?
2x, sir.
2x.
Right? So can you just tell me what will be the value of f dash of g of x? Like you have got f dash x. So in that, put this thing. What will it?
Cos x
Cos of
square. X
great.
square.
Cos of x square. Great, great. It will be cos of x square, right? Multiplied by what will you get over here?
2x, sir.
2x, sir.
2x. Right. This is your answer. Okay. Please give me. Okay, great work. So like this, you can like do about any function. Let us give it a try to this one. So you have got y is equal to, let us take, okay, secant of x square plus 3. Okay. So again, if you write it as f of g of x, right? F of g of x. So can you just tell me what will be your f of x and g of x?
Secant x, sir.
Great. And what about g of x?
X square plus 3.
Great work. So first, let us do this one. What is g dash x?
2x, sir.
2x plus 1
2x only, sir. X,
Great, 2x.
plus 0, sir.
Okay, so what will be f dash x?
Secant x
Secant
into
x tan x, sir.
tan x.
Great.
Secant.
Right? Everyone agrees with this?
Yes, sir.
Secant x into tan x. We have already proved it yesterday. So dy by dx. Dy by dx is basically f dash of g of x into g dash x. Right?
Yes, sir.
So can anyone just tell me? We have got g dash x already, right? We have got g dash x. Can anyone just tell me what will be f dash of g of x? I want to know this. F dash of g of x.
Secant of
See,
x square plus 3 into tan of x square plus 3.
great. How we will do this? See, what is f dash x, right? So in place of x, I need to put g of x. What is my
Yes.
g of x? X square plus 3. So everywhere I see x, in place of x, I will put x square plus 3. So it will be secant of x square plus 3 into tan of x square plus 3. Great work. Great. So this thing can be written as secant of x square plus 3 into tan of x square plus 3 into
To
2x.
2x.
This will be my answer, right? Let us try the case of one more nesting. So you have got your y as f of g of h of x. So like you can apply your trick again. This time what you do is you treat this whole thing. You treat g of h of x as one single entity u and treat your h of x as some entity v, right? So dy by dx is basically d by dx of f of u, right? Do you agree, everyone?
Yes,
Right?
sir.
So what I
Yes,
can do
sir.
is I can write it as d by du of f of u into du by dx, right? Everyone?
Yes, sir.
So how can
Yes,
this thing be written as? Can you tell me what will be d by du of f of u? What will it be?
sir. F dash u.
Great, f dash u. Let us have a look at du by dx also. Du by dx is basically d by dx of u. So u is g of h of x.
Yes, sir.
So over here, I have asked to represent your h of x as v. So it is d by dx of g of v, right?
Yes, sir.
Right. So it can be written as d by dv of g of v into dv by dx, right? Everyone.
Yes, sir.
Sir, I
Okay.
don't
So I will
understand.
just, is this correct, right? This is correct.
How, sir?
See, like it is d by dx of g of v, right? So I have divided and multiplied by dv. So over here I have taken dv and I have multiplied it by dv. So I have got dv by dx and over here I have got this thing. So can anyone just tell me what will be the value of d by d by dv of gv? What will it be? The derivative with respect to v of g of
Sir,
v. What will it be? This thing.
it will be G dash V.
Great. It will be g dash v. And what will be dv by dx? dv by dx. What will it be?
H dash X, sir.
Great. H dash x. Because v is h of x. So obviously it will be like this. Right? So I just come back and write my final answer. So my final answer will be f dash of u multiplied by g dash of v multiplied by h dash of x. Everyone agrees with this?
Yes, sir.
Yes, sir.
Anyone, any issue? Any
Sir,
issue,
I got
anyone?
it. Yeah, sir.
Ask. Vignesh.
So, in the second, third step, why did you write f, d of f? Here, sir. Right, left side. Third step,
Ask.
d of f of
Over
u by
here.
du. No, sir, this side, left side, sir.
Okay.
Yeah, sir. d of f of u by du.
Yeah. So like I had my variable. See, over here, what is happening? Like we were doing earlier also. I have got my variable in terms of u, some u. And now I need to differentiate it to x, like in some variable x. So what I do is I multiply and divide by du, right? So basically, first I differentiate it with respect to u, and then I multiply it by du by dx. So that is what I am doing over here. So I have got my function f of u. It is function in the variable u. I need to convert it into variable x. So what I do is I multiply and divide by du. So I basically first differentiate this thing with respect to u, my variable u, and then I multiply it by du by dx. Fine. So did you get why this thing is equal to f dash u?
Yes, sir.
Okay, got it? Got it? You can ask if you have any doubts. Okay, fine. So over here, the final result that we get, over here is this thing, f dash u into g dash v into h dash x. So can anyone just help me in substituting the values back and getting the final answer? What will it be? My final answer. So I need to substitute my values back. So it will be f dash of u. So I just substitute it as f dash of g of h of x
Yes, sir.
into g dash of v, g dash of
H
h of x,
H of
right?
X.
Into
into
h dash x.
Yes,
This
sir.
is my final answer. So we all observe a pattern. See, it was f of x, g of x, and h of x, right? inserted into each other. So what was happening is it was something like this, right? So like in the easy method that we had discussed earlier, what we do is you can approach from the outermost side. You approach from the outermost bracket. So let me just show you in the other way around only. So you have got this thing. You have got this function, right? So over here, your outermost function. What is your outermost function? Who will tell me? Vignesh.
F, sir.
Oh, great. F. So what it tells you is you approach from the outermost function. You differentiate the outermost function and keep the entities inside constant. You don't change it. Fine. So it will be f dash of g of h of x. Right. After that, you have completed this. So you move inside. After that, the function that you encounter is g of x. So you differentiate g of x and the entities inside g of x you keep as it is. Right. After that, you encounter h of x. So you differentiate that and the entity inside is x. So you don't need to do anything. So this is the final answer you'll get. Understood, everyone?
Yes, sir.
Really?
Yeah, sir.
Yes, sir.
Okay, let us give it a try. Let us give it a try in 4 cases also. Let us see if we can do. So you have got a function as a of b of c of d of x. Fine. I want you to tell me what will be the dy by dx.
A dash
Into
A,
E
B of C of
C of
D of
Okay. After that,
into B dash C of
D of X.
great.
into C dash of D of
D
into D,
X
D dash
Great.
D
Right?
dash X.
yes.
Everyone,
Yes, sir. Yes,
everyone
sir.
agrees? Yeah, this is correct. So what you do is you start from the outermost, level, then you keep on moving one step inside, right? You keep on moving one step inside, and then you just keep the inside entities as it is, right? So at a point, if you were differentiating this function a over here, so you keep the entities inside as it is and just keep it inside in this function. At the point when you are differentiating b, so you keep c of d of x as it is. When you are differentiating c, you keep d of x as it is. And obviously, when you differentiate the innermost function, so you have just got d. So you have got nothing to do. Okay, let us give it a try and see. Great. So you have got y is equal to, great. So you have got sine square of x cube. So just, can you just tell me for a moment, look at this function and just try to create a small web chart of this. Which function has been inserted inside which function?
Sir, inside
Cube is inserted in the X science, sir.
we have
Okay,
put
great. So Vignesh has told me that x cube is being inserted inside sin x function. Great. Is that is it like that's it, or something else is also done?
sir,
Yes, sir.
sine x
What?
Sine is in
sine square x inside
X square, sir.
Think again. Great.
have
X
put
square.
in
Yes,
This
sir.
whole thing is being substituted inside x square, right?
Yes, sir. Yes,
Yeah.
sir.
So basically, you have got nesting 3 times. So what can we do in this case? Who will tell me? You have got nesting 3 times. So just start from the outermost function. So you start from the outermost function. What function do you encounter?
X
What function do you get? X square. What is the derivative of x square? What is the derivative of x square? 2x. So when you differentiate this thing, you keep your inside stuff as it is. So what is your inside stuff? What is your
Sine
stuff inside?
of X.
Sine of x cube. Great. Sine of x cube. Right. So it becomes 2 into sine of x cube. Right. So you have completed this level. Now you move inside. What function do you get?
Sine.
Sine and
Sin x.
cos.
What is the derivative of sin x?
Cos
Cos
x.
Right? So when you differentiate this thing and you write the answer, you keep as it is, inside part as it is. What is your inside part?
Cos
X cubed, sir.
X cube. It is x cube, right? Right? So
Yes, sir.
it becomes cos of x cube. Right? After that, you completed this part, you move inside. What function do you get?
X cubed.
X
X cube. Is
Yes,
there
sir.
anything inside x cube? Is there anything
No,
inside
sir.
x cube?
No,
So
sir.
you just differentiate it as it is. So can you tell me
3x
what is the
square.
differentiation? 3x square. Great.
Square, sir.
Sir,
So this is your final answer. Yes, Vignesh?
can you tell me why did we inserted sin x into x square?
Yeah, because it is sine of x cube, right? It is sine of x cube. So how will you get this? So it is basically sine of x cube whole square, something like this. So it is basically like you can just see it inside of x square. We have substituted sine of x cube, right? Right, Vignesh?
Yes, sir.
Yeah. So like this thing again, we can nest it and write it as sine x being inserted inside x cube. So actually, I just wanted to give you a very small trick that we have discussed already, but I'll just give you again. That whenever you land into such a case wherein you need to solve, like you need to do questions. So what you do is just remember this very small trick that use only two levels at a time. Okay. Create only web chart of two levels at a time. So I'll show you how the previous question like could have been easily thought. So for example, you have got sine square of x cube, right? So basically it is, what is it? So it is x square being inserted, right? Sine of x cube being inserted inside x square. Do you all agree with this?
Yes.
Everyone agrees with this? Right. Right. So what I say is that you just keep two levels at a time. Fine. So you get this thing. So you just approach from the outermost side, you get 2x and just substitute this thing inside. So you get 2 of sine of x cube, right? After you have completed this, you get this function and now you create the function of this. So what will be the web chart of this thing? So inside sine x, you have created x cube, right? Everyone agree?
Yes, sir.
Yeah. So again, like you do the same thing, you approach from the outermost side, you get cos x, right? You get cos x. So in place of cos, like in place of x, you will again keep your inside part as it is. So it will be cos of x cube. You have completed this, you move ahead, you get this function, x
3x.
cube. So x cube, 3x squared directly, right? Anyone who was present in the common syllabus to JEE and NEET students? I guess Gayatri was there.
Yes, sir.
Gayatri and Ashrita. Okay. So I hope you are able to do the questions now, like based on the trick. This trick was discussed earlier, right? Using only two levels at a time.
Yes, sir.
Yeah, right. This trick was discussed earlier, right?
Yes, sir.
Okay, great. I'm glad you remember. Okay. So yeah, like this will really help you because at a time if you operate on only two levels, you will not get confused. Otherwise, it will be really messed up and you can get confused very easily. Fine. Okay, let us give it a try to this one also. So you have got y is equal to e raised to uh, cos cube of x raised to 4 plus 1. Fine. So just give me one leveled web chart of this, just one level. So can anyone just tell me, if I ask you to draw the first level of this, which function is inserted inside which function? Just see the function from the outermost level and tell me. Anyone?
E raised to x cos cube of x.
Great. Great. Correct. Everyone agree with this?
Yes, sir.
Yes.
Right? This is the outermost level of the question. Great. This is the outermost level. X raised to x. Who will tell me derivative of e raised to x?
E raised to x.
Yeah, great. It is e raised to x only. The derivative of e raised to x is e raised to x only. Great work. So e raised to x derivative is e raised to x. So can you tell me what will be the first term that I get over here? First term. Anyone? It is really simple, right? Because inside e raised to x, you have substituted this thing. So you just substitute this thing directly in place of x, right?
Yes, sir.
Yes, sir.
Yeah.
Same one.
So you'll get e raised to cos cube of f
x
x
raised to
raised to 4
4
plus
plus
1, right? So you completed this level. Now you draw the blunt graph web chart of this thing. So you have got cos cube of x raised to 4 plus 1. Can you tell me which function is inserted inside which function?
X cos of x raised to 4 plus 1 is inserted in the x cube.
Great work. Is inserted inside inside x cube. So we approach from the outermost side and get the first function as x cube. Can you tell me what is the derivative of x cube?
3x square, sir.
2x.
3x
Great. Right? 3x square. So anyone can just tell me what term will come over here?
In place of x, we'll get cos of
x
Great.
raised to
In
4
place
plus
of x, great. So in place of x, we will keep this thing, right?
yes, sir.
So it will be 3 cos square of x raised to 4 plus 1. Everyone agrees with this?
Yes,
Yes,
sir.
sir.
Okay. So we completed this level, we move inside. Can you tell me which function has been inserted inside which function?
Sir, inside cos x,
x raised to 4 plus 1.
x 4 plus 1.
Okay, great. So you approach from the outermost side, you get the first function as cos x. What is the derivative of cos x?
Minus sin x.
Sin x.
Great. So what will be the next term that you get over here?
Minus sin
Minus
of
sin x x raised to 4 plus 1.
Great. It will be minus sine of x raised to
X
4
raised to
plus 1.
plus 1.
Right? You complete
Yes,
this,
sir.
you get this. Is there any need to draw a flowchart of this thing, x raised to 4 plus 1? Is there a
No.
need for a flowchart? No. There is no need for flowchart
No,
because
sir.
it is directly like it is a polynomial. Right? Yeah. Great. So you have got this. So tell me, it will be, what will it be?
4x cube, sir.
Derivative of this thing.
4
4x cube.
into
Great.
x.
Great. So this is your
Four.
final answer. Right?
Yes, sir.
Everyone? Okay.
Yeah.
So, like for the time being, I just want to ask you. You have got a function. I want you to. I want that all of us will derive one thing today. Fine. So first of all, any one of you knows what is the derivative of x raised to half or square root of x? What is it? What will it be? Can we find it? We already know it, right?
1
We
by
already know what is. Tell
1
me
by
1
2
by
x
2.
raised to minus 1 by 2,
x.
sir.
Minus
Great.
1 by
Yeah. Because we already know x raised to n, right? Derivative of x raised to n, we already know. So it will be like this. So it is 1 by 2 root x, right?
Yes, sir.
Yeah. Because n can be any real number. It works for any real number. Okay, fine. Great. So yeah, this is correct. So let us look into, let us derive one small thing. So you have got your y as ln of x, right? Natural log of x. Let us see if we can derive this thing using our chain rule. Is it possible? I feel it is possible. So see what do we have over here? We have got y is equal to ln x. So x can be written as e raised to y, right? E raised to y. Property of logarithm. Everyone agrees with this, right?
Sir.
Yes, sir.
Yeah. Now I want you to differentiate both sides with respect to x. I want to differentiate both sides with respect to x. Can you tell me what will happen if I differentiate the left side with x, with respect to x? Derivative of x with respect to x. What is it?
One,
By
sir. One,
How
sir.
much? 1.
One.
Right? Right? 1. Everyone?
yes, sir.
Great. So
So I
in the
didn't
right
get
hand
it.
side, sorry,
So I couldn't understand.
I am just asking you to
तो वन
differentiate both
कैसा आया
sides
सर
with respect to x. It is like dx by dx. And over here I have got d e raised to y by dx. So what is dx by dx?
One,
Like
sir.
derivative of x with respect to x. What is it?
1,
1,
sir.
right?
वन
Yeah, 1.
Yes, sir.
So over in the right hand side, I have got dy dx of e raised to y. E raised to y. So I can convert it as dy of e raised to y into dy by dx. Any issues, anyone?
No, sir.
No, sir.
Any issues? Anyone? Okay. And the value of this thing I have already got as 1. So can you tell me what is the value of dy by dx? Dy by dx is what? First of all, what is d by dy of e raised to y? D
One,
by
sir.
dy of e raised to y.
E raised to y.
One.
Raised to one,
Huh.
sir.
What is the derivative of e raised to x with respect to x? What is it?
E raised to x, sir.
E raised to x.
Yeah, correct. It is e raised to x. Correct. So derivative of e raised to y with respect to y will also be e raised to y. I have just changed the variable from x to y. Vignesh.
Yes, sir. I get it, sir.
Okay. Fine. So yeah, I got this. So can you just tell me what will be the value of dy by dx? It will be 1 by e raised to y. Everyone agree with this?
Yes, sir.
Right? Because I've just taken this as reciprocal in the right side. So 1 by e raised to y. My value of 1 by e raised to y. So it can be written as 1 by x. See, because e raised to y was equal to x. So if my y is equal to ln x, my value of dy by dx is 1 by x. Got it, everyone?
Yes, sir.
Anyone who has any issues? We have just proved it. Like normally
D
we remember it, but
raised to y. How
right?
how it came, sir?
Ask us
Y by
what
dx is equal to 1 by e raised to y, sir. Yes,
see,
sir.
okay, not an issue. Okay, just a minute. I'll do that again. So can you just tell me what will be the value of dy by like d by dy of e raised to y? Derivative of e raised to y with respect to y. What will it be?
E raised to y, sir.
It will be e raised to y. Great. And I keep this dy by dx as it is equal to 1. So what will be my dy by dx? Can I take this e raised to y down over here? So it can be written something like this.
Yes, sir.
Now is it correct? Is it correct now? Do you agree now?
Yes, sir. It is correct.
Tell me. Okay. So it is 1 by x, right? I hope you got it now.
Yes,
Got
sir.
it?
Yes,
Okay, great.
sir.
Okay, great. Let us do this question really quick. So over here you have got. So now I'm pretty sure that you have understood chain rule. And anyways, we had done it earlier also, so not an issue. So you have got square root of log of sine of x square minus 1. So first of all, I just want you to create a very blunt web chart of this thing and tell me which function is inside which function. Just look at it bluntly and tell me.
Under root x. Sir,
Tell me. Who will tell me? Just draw the first level of this thing and tell me.
under root
First level.
x,
Inside square root of x, what do we have inside square root of x?
log of sine of x square minus 1.
Okay, great work. So yeah, this is correct. You have put basically, you can see it also that inside of square root of x, we have put this thing, log of sine of x square minus 1. Everyone agrees with this?
Yes, sir.
This is the first level. This is the first level of the problem, right? So you approach it from the outermost side, you get square root of x. What is the derivative of square root of x? We have just calculated it right now.
1 by 2
It is
root x.
1 by 2 root x. So when I get 1 by 2 root x, I can just substitute this whole thing inside this, everyone,
Yes, sir.
right?
Sir,
Any doubt, anyone?
No, sir.
Okay. So you can just directly put it as 1 by 2 square root of log of sine of x square minus 1, right?
Yes, sir.
Yes, sir.
Okay. So you completed this level. Can you help me with this one and tell me which function is inserted inside which function?
Sir,
Under
inside
log
sine
Tell,
of
tell.
x square
sine
minus
of
1.
1 is
Inserted, sir.
log x, sir.
Sine of x square minus 1 is inserted inside log x. Great.
Log x.
Yeah,
Yes, sir.
great, correct. So you approach from outermost side, you get log x. What is the derivative of log x?
1 by x.
1 by
1 by
Right?
x.
Yes,
Right,
sir.
1 by x. So you can write it. So in place of x, I need to
One.
substitute this thing, sine of x square minus 1, right?
Yes,
Yes,
So I
sir.
write it as 1 by sine of x square minus 1, right? Great. I completed
Yes,
this.
sir.
Can you help me with this one?
sir. Inside sine x.
X square minus 1 is
Inserted.
Right. I approach from outermost side, I get sine x. Derivative of sine x is cos x. So what will be the next term that I write over here?
Cos of x
cos of
square
x square
minus
minus
1.
Great work. Do I need a web chart for x square minus 1?
No, sir.
No.
2x.
I can just directly write the derivative as 2x.
Right.
So this is my final answer, right?
Yes, sir.
Okay. Now let us
Yes, sir.
like revise a bit from the yesterday and try to apply it along with chain rule. Fine. So let us see if we can do that. So you have got two functions in division or okay. So in the first case, we will take something to be easy and then we will increase the level. Fine. You have got this thing. So you have got x cubed plus 1 multiplied by sine of x square. So you have got two functions in multiplication. Okay. So the first function is x cubed plus 1. The second function,
Sine of x square.
great. Can you tell me what is the derivative of the first function?
2x 3x square.
Yes, sir.
What is the derivative of the second function? Can we calculate the derivative of the second function?
Yes, sir. Cos x square into 2x.
Great. We have done this now only, right?
To
We have
2x.
just done it today only.
Yes.
Yes, sir.
Yeah, we have done it today only. Okay, great. So how do you do two functions when two functions are in multiplication? How do you solve the derivative? Like how do you do the derivative? Two
First
functions
term,
in multiplication. Great. So you take the derivative of the first term, keep second as it is, and then the other way around. So you take the derivative of the first term
Sir,
and keep second as it is. Yes, Vignesh.
I think we should put first function as it is, and we need to be differentiate the second function.
Yeah. So like, yeah, so that is what we are doing. We differentiate the first function, keep the second as it is, and after that, you differentiate the second function and keep the first as it is.
Yes.
So at a time, you differentiate only one function. That is what we are doing. Either you differentiate the first function first or you differentiate the second function first. At one time, you should only differentiate one function at a time. So you have got two functions over here. One function is x cube plus 1. Another function is sine of x square. So in the first try, I have differentiated the first function. And in the second time, I will be differentiating my second function. So now I keep the first function intact and now I differentiate the second function. So this is my final answer. Got it, Vignesh?
Yes, sir.
Yeah. So like at a time, you should differentiate one function. So this is how you should work, like in multiplication. We had discussed this yesterday, right?
Yes, sir.
Okay. So let us try this one. So you have got a functional equation, okay? So x and y, x is a variable and y is a function that's dependent on x. So you have got x raised to y is equal to e raised to x minus y. Can anyone tell me? So the first thing that we do is obviously take logarithm on both sides. So when you take ln on both sides, ln of x raised to y is equal to ln of e raised to x minus y. Can anyone tell me what will happen to the right side? What will my right side become? Like this thing.
For
ln of
x.
e raised to x. How much?
x minus y into ln of e raised to.
Okay, great.
Y.
So x minus y into ln of e. What is ln of e?
1, sir.
Yeah, it is 1. So it is my final thing becomes L x minus y, right? X
Yes,
minus y.
sir.
And what about this thing? It is ln of x raised to y. So I have a power rule in logarithm?
Yes, sir.
What happens to the power? What happens to it? Power.
Come to the front of the logarithm. Y ln of x.
Y of x.
Yeah, correct. So like if everyone remembers it clearly, there is a rule that ln of x raised to c is basically c times of ln x. So this power comes in front. So
Yes,
this thing can be
sir.
written as y of ln x, right?
Yes,
Y
sir.
into ln of x. And this thing becomes x minus
X.
y, right?
Yes, sir.
So can we write our y in terms of x? How can we do it? So y into, so I'll just bring it this side. It can be written as ln x plus 1 is equal to x. So my value of y becomes x divided by ln x plus 1. Right, everyone?
Yes, sir.
This is correct. Got this?
Yes, sir. Yes, sir.
How would you differentiate this thing? I want to find dy by dx. How would we do it? we have got two functions in division. How would we do it? How would you do it?
Differentiate with respect to x.
Yeah, I mean, how would you do that? That is what I'm asking. Like, you have got two functions in division. How do you do that? So if you don't remember dy by
It
dx,
Differentiation of first
first you,
function into
great.
second function
So you
minus
differentiate the top minus
Yes. I denominator
whole divide
square.
by
differentiation of second
square.
function
Okay, great,
into first function by
denominator.
g of x.
great. So you differentiate the top first, right?
Yes, sir.
Okay, so can anyone just tell me? So over here, what we do is we differentiate the function on top first. So you differentiate that thing, keep your bottom as it is, minus, you do the other way around. So you keep top as it is and differentiate the bottom,
1 by x
By
right?
whole. Yes, sir.
So
x.
your top becomes ln x plus 1 minus 1, right? Ln x plus 1 minus 1 whole divided by ln x plus 1 whole squared. So
Yes.
it becomes ln x divided by ln x plus 1 whole squared.
Whole
Okay.
square.
Is this correct, everyone?
Yes, sir.
Yes, sir.
Great. So yeah, let us see if we can do a few more. So I've got y as square root of x square plus a square. Can you tell me? A is any constant. Can you tell me what will be the derivative of this thing? So the first function that you encounter is basically square root of x. So
Yes.
inside square root of x, you have put x square plus a
X
square.
a square.
So what is the derivative of square root of x?
1 by 2 root x.
1 by 2 x.
Right? It is 1 by 2 root x. So can you tell me what will be the derivative? Like what the term will come over here? What will be the
1
term?
1
into
by 2
x
into 1
by
square plus.
root x.
Right?
X
Yes,
It
sir.
will be this
Yes, sir. Yes,
1
sir.
by 2 square root x square plus a square, because in place of x, I need to substitute x square plus a square. Great, I'm done with this. So x square
Yes.
plus a square, what will be the derivative of x square plus a square?
2x, sir.
2a.
X.
2x.
2x.
2x only.
Yeah,
Yes,
only
sir.
2x because a is a constant. So 2 and 2 will get cancelled. I'll get my final answer as x divided by under root
X.
x square plus a square.
Yes, sir.
Okay, let us do this question really quick. So you have got y is equal to ln of x plus square root x square plus a square. So obviously inside ln of x, we have substituted this thing, right, everyone? Everyone agree?
Yes, sir.
So like
Yes,
from now
sir.
onwards, I would want all of you to like just do it manually. Like instead of drawing the web chart every time, you should be able to create your web chart in your mind and do it in a faster way. So obviously you can see that inside lnx, we have substituted this long function. So what is the derivative of lnx?
1 by x and 1 by
1 by
x
x.
plus x square plus a square into.
Great. Great. So
Do
this is the first term, right? Because now
yes,
we are done with ln. Now we'll just directly start differentiating this thing. Can you tell me what is the derivative of x plus this thing? So 1 plus
and
and the
plus
derivative of this thing.
1
So now so it will be this
1
thing, right? X divided by square root of x square plus a
yes
square, right?
yes, sir.
yes
So you
sir.
can just take it out common. So when you take it out common, your numerator gets x plus square root x square plus a square, and it can get cancelled out with the denominator. So my final answer remains as this thing,
1 by under
right?
root x square
Because
plus a square.
because when you take this common, your numerator and denominator will get out cancelled. So you'll get this thing, right, everyone? Agree,
Sir,
everyone?
Yes.
What?
sir,
Ask.
can you
Can you tell me the what
explain
format
again?
of second function, sir?
Yeah. Can you tell me what, Vignesh?
Second step, sir.
Yeah, see, like inside lnx, we had substituted this function, right?
Yes,
Right?
sir.
Yeah. So after I had completed my ln part, so this was my ln part. I completed my ln part and moved ahead. So I just required to differentiate this function. So when I started differentiating this function, I get x plus square root of x square plus a square. So derivative of x is 1. So I get 1 plus. Then I differentiate square root x square plus a square. And I have already done it above. So differentiation of square root x square plus a square is x divided by x square plus a square. So I get this thing, right? Correct?
Yes, sir.
Yeah. So I just like take out the common thing and I common the denominator. So when I do that, the numerator and denominator becomes equal and it gets cancelled out. So I'm just left with this thing. Fine. So fine, let us like do some real questions now, like where it is actually being used, where this thing actually comes into picture. So you have got limit x tends to 0. Okay, you have got x square plus 1 raised to 1 by 3. So it is basically third root minus 1 minus 2x raised to 1 by 4 whole divided by x plus x square. Can anyone tell me which form of limit is this? Which form of limit is this?
0 by
Anyone?
0.
Okay, great. So you can just directly substitute your values and obviously you'll get 0 by 0, right? 1 minus 1, 0 by 0. It is 0 by 0, so I can go for L'Hopital's rule. Everyone, should I go for
Yes.
L'Hopital's rule?
Sir,
Okay, great. So let us apply the L'Hopital's rule. So first help me differentiate the denominator. What will be the derivative of the denominator?
1
1
1 plus 2x, sir.
1 plus 2x. Great work. Now let us do the numerator. So you have got x square plus 1 whole raised to 1 by 3. Can you tell me what will be the derivative of this thing? Which function is inserted inside which function?
sir, inside
Hmm.
cube root
Tell
of
me.
x.
Hmm. X square plus 1 has been inserted, right?
Yes,
Yes, sir.
Right? Yeah, it is correct. So basically inside x raised to 3, x raised to 1 by 3, you have substituted x square plus 1. So obviously you can do it now. So can you just tell me what will be the derivative of this thing? You approach from the outermost side, you get x raised to 1 by 3. What will be the derivative of x raised to 1 by 3?
1 by 3 x raised to 2 by 3
Great.
minus 2.
X raised to 2 by 3. Are you sure? 2 by
2
3.
by
Are you sure it
minus
will
2.
be 2 by 3? minus 2
Minus-
by 3, right?
Yes.
1 by 3 minus 1, right? But is this thing like what will be the term that comes over here? The term that comes over here, what will it be?
In place of x,
1
x
by
square.
3 x square plus 1 raised to minus 2 by 3, sir.
Great work. Minus 2 by 3. Great. So after that, I do this, I am left with x square plus 1. What is the derivative of x square plus 1?
2x.
2x, sir.
2x.
Great. Minus, right? Now I got 1 minus 2x raised to 1 by 4. Can you tell me? 1 minus 2x raised to 1 by 4. So which function is inserted inside which function?
X raised to 1 by 4 is
In
x.
Inside x raised to 1 by 4, 1 minus 2x is
1
inside.
2x is inserted, sir.
So can you tell me what is the derivative of this thing, outermost function, x raised to 1 by 4? What is the derivative?
1
One
by 4 x raised to
to
minus 3 by 4.
minus 3. Minus 3 by 4.
Minus 3 by 4, right?
3 by 4.
Sir.
Great work. So what will be the term that I write over here? What will it be?
1 by 4
1 by 4 into x. 1 minus 2x raised to minus 3 by 4, sir.
4.
Great. So I completed this level. What is the derivative of 1 minus 2x?
Minus 2, sir.
Yes.
Right? Is this
Yes.
correct?
सर वो कैसा है सर 1/4
Yeah.
1 minus 2x minus 3/4
Okay. See, like it is, you know what is derivative of x raised to n? It is n x raised to n minus 1. So dy by dx of x raised to 4, 1 by 4, sorry, x raised to 1 by 4 is 1 by 4 x raised to 1 by 4 minus 1. So 1 by 4 minus 1 is minus 3 by 4. Fine. So it is minus 3 by 4. Yeah. So over here, again, your limit x is tending to 0. So is this an indeterminate form? Everyone, is this an indeterminate form?
No, sir.
No, this is not an indeterminate form, right? Can you just calculate the value fast? So x is tending to 0. So this first term is already 0. And your denominator is already 1.
Answer will be
So it
0.
becomes,
0.
0.
answer is
0.
0.
Sir.
Answer is 1.
Answer is not 1, answer is half. According to me, answer should be half. See,
Invite
x is tending to 0. See, just listen. X is tending to 0, so this whole thing becomes 0, right?
Yes, sir.
Minus
Yes.
1 by 4 into 1 minus 0. So it is 1 raised to minus 3 by 4 into minus
Right.
2 whole divided by 1.
Minus 1 by 2, sir. Answer.
No, sir.
No, it is
plus
not minus. It is plus 1 by 2. Because minus and minus. So it will eventually become plus.
Yes,
Calculation
sir.
error. Calculation error करते हो तुम लोग. ठीक है. Okay, not an issue. So I got it. It was a calculation error. It shouldn't actually be fine. Okay, let us do one last question before leaving today. This one is also really good. So you got limit extends to 2. Okay. You have got 60 plus x square raised to 1 by 3 minus 4 whole divided by sine of x minus 2. Can you tell me which form is this? Like it is obviously really easy to guess. Which form is this?
Sir.
0 by 0, obviously. If we are going for differentiation, then obviously it is 0 by 0 form. Like, really easy to guess. So, like, obviously, we will go for LH rule only. Then only I have given the question. So, can you just tell me what will be the derivative of sine of x minus 2? Anyone?
So it
Sine of
be-
x. It
Cos,
will be,
cos x minus 2, sir.
yeah, great. Cos of x minus 2. Because it is a linear function, so like it is really easy. Like instead, like inside sine x, we have just substituted x minus 2. So the derivative of this thing is 1. So it is just simply cos of x minus 2, right? Really easy to guess. Now comes the main part. So you have got 60 plus x square whole raised to 1 by 3. Can you tell me 60 plus x square raised to 1 by 3? Which function is inside which function?
Under root x
X raised
Hmm?
to
plus x
1
square is inserted, sir.
by
60
plus
plus square.
square is
X square. Great. Yeah. This thing, right?
Yes, sir.
So you approach from outermost side, you get x raised to 1 by 3. Derivative is 1 by x raised to x
3
raised
Minus
into
2 by 3.
2 by 3.
x raised. So what will be the term that I write over here?
1
1
by
by
3, 60 plus
60
x square raised to minus 2 by 3.
Minus 3.
Into multiplied by
2x, sir.
2x.
2x,
Great.
sir.
Limit x is tending to 2. Is this an indeterminate form?
Mm,
Oh, sir.
no, sir.
No, it is not an indeterminate form. So can you just tell me the values? So you have got 1 by 3 into 64 raised to minus 2 by 3 into 4
4.
divided by what is cos of 0? Cos of 0.
1, sir.
Sir.
1.
Cos of 0 is 1. So 64 raised to minus 2 by 3. Anyone? 64 raised to minus 2 by 3. 64. First of all, 64 raised to 1 by 3. What will it be? Cube
4
root of 64. 4. Right? 4.
Yes,
And
sir.
then 4 raised to minus 2. 4 raised to minus 2 is 1 by 16.
Yes, sir. 1 by
So
12,
you get,
sir.
so into 16. Yeah, 1 by 12. Correct.
1 by 12.
Right, 1 by 12. Great work. 1 by 12. Okay, so I got a really good question for you. So this is your homework question for today. See, I just hope that now all of you will be able to solve all the questions related to limits. Okay. So all the questions that you have in limits chapter should be completed by now. So you have got this limit extends to 2, tan of x minus 2. See, like I know you will be confused why we are doing limits again. This is because earlier know about chain rule. So we weren't able to solve the questions derivatives of complex functions. But now we have understood chain rule, so we are able to do it. So you have got tan of x minus 2 multiplied by x square plus k minus 2x plus, sorry, minus 2k whole divided by x square minus 4x plus 4. Okay, the value of this limit is 5, so it is asking you to find k. How will you do it? Anyone? How would you do it?
Differentiation.
Yeah, obviously, like that is why I've given the question. So I don't know why you are not answering. So yeah, and just one more question. So yeah, we've got limit extends to 0. You've got 4x minus 1 raised to 1 by 3. Okay, then you've got plus a plus bx whole divided by x, and this value is 1 by 3. So find ab, a multiplied by b, or you can find a and b separately also. So if you get a and b, then only you will be able to calculate ab. Okay, so that's it for today. And for like practice problems, you can do this limits part. So over here, you have got many questions related to chain rule also. Okay, fine. That's it. Sir, please end the class.
All right, sir. Thank you, sir.
Thank you. Thank you.
Students, join the next session.